Well, welcome to Chapter 11, the second part, where we'll talk about just how to compute some of these capital budgeting methods using Excel. And for capital budgeting, you can just use this Excel. So we're in Applia doing the work there. Pull this file open. It's under our class under handouts in my.usf. Pull this file open and use this as a way to calculate what you need to do. And it's really nice because you can just use this to make adjustments very easy. So they're going to walk us through examples they gave you in the book. In the PowerPoint, use projects S and L, but with different numbers. And they're using S and L also in the book with different numbers in the PowerPoint, of course. And they walk you through the mechanics of how to do these. So NPV is showing you two projects, each with an initial cost of $1,000, and then cash flows that are ultimately different and just timed differently. S is you get a lot of cash flow right away, and it goes down. And L, the cash flows are small, but they go up. Okay, so you kind of do that on purpose to show it, just to illustrate how they're different, how you get different answers. And so remember that for NPV, as long as I get a positive number, I'm good. I would choose that project. So for S, it's 78. For L, it's 100. The good news, both are above 0. So if I could choose both, if they're independent projects and I could afford it, I could do both projects. If they're mutually exclusive, I would probably go with project L because it's going to give me the highest return. And it's basically that number represents how much wealth we're adding to the company by taking on this project. So the theory behind each one is it is taking in a sum, the present value of all future cash flows. And that's what the formula is doing right here. It's taking the present value, adding those up compared to the initial cash outflow. And as long as the future value of all future cash flows, the present value of all future cash flows are more positive than the initial cost, we're good to go. Project L is what I want to show you, though. It has the NPV formula in it. Project L does. Okay. So Project L, I'm going to double click on that, and you can see that 10% is here, the initial cost of 1,000, and a whole bunch of positives here. So let's just say you have an Applia problem that says to do the net present value for a project, for a company, and you'll have several of those, and you need to compute that. And you can just come over here and play with this Excel and make it work to fit your needs. And again, you can't break these Excels because you can always open a brand new fresh one from my.usf. There's always a good one out there, so don't worry about breaking these or messing them up. You can't do it. Just go get a new one. That's all you got to do. And so let me just show you an example here. Let's just say we had a project with a WACC of 12%. And let's just say it had maybe 5, 6, 7 years worth of cash flow. So I'm going to double click on this so you can see that what it's doing is bringing 1, 2, 3, 4 periods. Let's just say we had a project that had actually maybe even 10 periods. So I'm going to do 5. And this is just illustrative. What I'm typing in for these numbers actually don't really matter for anything. They're nice just to know that you got all the cash flows covered. And then what I can do is I'm just going to overwrite this formula here because this formula doesn't mean anything. And I'm going to just type in like 700. I'm just making up numbers for future cash flows. We'll just go up by increments of 50. So bear with me for a second while I type those in. Okay. And so I've got a project with 10 years at 12%. What's the NPV? So I have to adjust my formula. Okay, so this formula is only picking up the first 4 periods. So I have to drag that across and just make sure I pull in the 10 periods. Hit enter. And the present value is now 2,154.91. So the reason I'm giving you this example is just so you can use that to do the work in Applia. I could have changed this initial cash to be a negative 2,000. Whatever I want that to be to fit the problem that I'm working on. Okay, so you can just take this initial Excel formula that's right here and just play with it to compute what you need to in Applia. Project S are just showing us graphically how this works, the mechanics behind it. For L, they just gave us the formula. Okay, so that's my suggestion when you do this work in Applia. Let's do the same thing for IRR. Okay, so I've got the two different companies here for S and L. I'm using the same data as above. And so they're showing us for both graphically how this works. And you can just see that they give us an IRR formula right there. So I'll just go right there. So IRR is the sum then of those cash flows, and it computes what the return is. And you can see that this isn't even a, this is just a, it's not even a number in a cell, it's just a graph more, or just a text. It's not actually even a number in a cell, that 14.489. Remember, the theory behind IRR is what's the rate of return that will force the NPV of all future cash flows to be 0. And so we're showing us like this on purpose to say, if I just do IRR for this project, it's 14.489, and then if I put in this here, and basically all these are coming in at 14.489, it's 0. So that works. So I know now, we just proved it, that this rate of return is NPV of 0 for both projects. Okay, so IRRs are a really simple formula. So let's just go back and compute the number. Let's use this one here, and let's just say, again, we're just going to go back and overwrite, or just use more numbers here. So the numbers I used up above, let's see what those were. I started at, oops, I went way too far, 700, and then I just did increments of 50. Let's do the same thing. Let's go to the second one. Okay, so I'm going to start right here. Okay, I'm going to go with 700. Actually, I'm going to put the years here just to make sure I've got, and these years, and that doesn't even matter if they format to dollars. It doesn't really matter at all. And just to make sure I've got 10 cash flows. That's the only reason I'm putting those there. They don't come into the formula at all. So I got 700, and then I'm just go increments of 50 again. And I could copy and paste, but I'm using my Mac, and it's not as easy. So I'm just going to enter the numbers. I don't usually use my Mac for Excel. Okay, so now I can look at my IR formula. And all I got to do again is drag the formula to make sure I'm including all the years, and voila, I'm done. So I got a really nice rate of return with this project. If I change it to be like -2,000, it will go down. Okay, now it's 21. But that's all I have to do for IRR. So when you get an IRR form, question in Applia, come over here. Okay, skip the MIRR stuff. I'm not going to have you do anything with that when you do the work in Applia. Let me scroll down some more here. So it's slowly scrolling down. I know it's a little slow. MIRR, that's one you need to know. Okay, so MIRR, if you remember the PowerPoint, what we do is we calculate the terminal value of the cash flows. Okay, the terminal value is what's the future value of the cash flows in the terminal year, the last year of the project. Okay, so for Project S, it was a -1,000, had positives of 500, 400, 300, and the fourth year was 100. So the fourth year number is the fourth year number, it's $100. But then I take the 300 and advance it forward, compound it forward by 1 year at 10%, which is the WACC, 400 2 years at 10%, 500 3 years at 10%. And I get the terminal value. So the terminal value of all the future cash flows is 157,950. And then I use my MIRR formula, which is right here. And they gave us a couple different things here. They're using G124, which is just this number here. They computed the rate for us, and then we used the MIRR formula right here. Okay, so I went 10% WACC, and then it brought in all these things here. Okay, so graphically they're showing us what's happened, but the MIR formula itself is just doing that for us, which is actually the same thing as the rate formula. They both give us the same answer. Oops, I gotta hit escape. There we go. Okay, they're both doing the same thing for us. They give us the same answer, just so you know. And they're going to show us that. So the rate formula used the number of periods, present value, terminal value. The MIR formula used those. Okay. they're showing us on the right hand side if you want to build these from scratch. This is what you'd see in Excel if you just built one from scratch. But all you got to do is keep doing what I've been showing you how to do, and I'm just going to delete this because it's in the way. But I'm going to show you. Make that go away. I'm going to show you again kind of what we can do before. So let's just go with my 5. Actually, I should do the one below. We've been using the other project. So I'm going to just get rid of this too. And again, you can't break this Excel because if you think you messed something up, go get a fresh one. So I'm going to add my years again. And I'll start at 700, and I'll go with just increments of 50. Okay, and then I'm going to go down here and use this formula, and all you got to do is drag across again. And my MIRR is now 24.73. Or if I had a higher initial cost, let's say 2,000 again, like I've been using, it would drop down then to 1638. Okay. The other ones are different now because I haven't played with those. So that's how you can use the MIRR formula in Applia. So this file is your friend when you're in Applia. Just come over here and do your thing. I'm not doing anything with NPV profiles in Applia, so don't worry about that. But there is a section down here regarding the payback, so we got to go look at that. So bear with me while it gets down there. I'm not quite as adept with Excel in the Mac as I am with Excel in Windows. But I have to use my Mac to do the recordings because I use QuickTime and upload it to YouTube, which is way easier to do on the Mac than it is in Windows. So here's payback. Here's an example of the payback, and I showed you that in the PowerPoint. The key is when you get these in Applia, you may have to adjust these formulas a little bit, okay? Because what it's doing is it's saying between years 2 and 3, this went positive, right? So year 1, it was still a cumulative negative. In year 2 is a cumulative negative, but in year 3, it was a cumulative positive, the 200. So my answer is 2 point something, right? Because between years 2 and 3, it goes positive. And so the formula is acknowledging that. So it's 2.33, okay? So the formula is 2 plus the absolute. I'm using absolute because you have to actually take a positive 100 and divide it by 300. But basically your cash flow in year 2 divided by your cash flow in year 3. So those two numbers. So I have to adjust the formula to account for that. So you may have to move these cells to make that work. That's my hint for you. Okay. And the same thing down here with discounted payback. You have to compute what is the present value of each of these cash flows. Okay. Now they're showing you how to do this with a formula here. They're not using the present value formula. You could insert the present value formula there to do that though. Okay. But then again, just make sure that this formula, it has to be set on the year that it went positive and divided by the right two numbers. We just know that between 2 and 3 it went positive. So the answer is 2 point something. Okay, and it's 2.95. Remember that discounted payback is 2.95 for discounted payback, and it was 2.33 for regular payback. Okay, so just something to keep in mind. You'll be doing a few of these in Applia. And then if you want to, the chapter uses these examples. This just shows you then the self-test questions that were in the book. If you want to compute those and look at them as examples to follow, here's a couple more payback examples for you to look at. Okay, so this file will be your friend when you do the work in Applia. Just pull it open. You can't break it. Don't worry about that. I always have students who get worried about that. There's always a fresh copy of the file in my .usf, so do what you want with it. You'll be just fine. If you have questions, let me know.